afternoon. This is Specify Talks. This is the first one of the series, and we're very glad today and pleased today to introduce Keith Scully of Grant. And my name is Paul McAlister. I'm a local architect and we specialise in Passivhaus housing, so I'll be very interested to speak to Keith today.
And my name is Paul Jenkins. I'm here with Paul. My own company is Technoplan and I specialise more in sort of renovation projects. And again, looking forward to having a chat to Keith today.
Yes, so Keith Scully, obviously Grant Engineering. We're based down in Birr, County Offaly, and I am the training manager. So we would train approximately about 900, maybe 1,000 individuals every year at this stage from all walks of the industry, from plumbing and heating contractors, electricians, through to all of the professional side of the trade as well, including lots of the merchants. So it's one aspect of a very large company, thankfully, that's going very, very well.
Thank you. So I suppose we're here today to learn about Grant and to hear about Grant. My experience of Grant is Grant boilers. I've seen them becoming more and more popular over the last 20 years. And I was saying earlier that I've just put one into a holiday home in the North Coast, and it was recommended by the plumber, the local plumber, so that's a good plug for Grant boilers. Now that was an oil boiler, but I believe you do heat pumps and a whole range of things as well.
Yeah, the company itself, I suppose, began initially with Stephen Grant, and Stephen was a fitter by trade, and he began making solid fuel back boilers at night time. And he began in a garage that was 16 foot by 16 foot back in 1978. And now at this stage, we have over 20,000 square metres of a manufacturing plant based in Birr, County Offaly. There's over 400 people working there. The factory itself is running 24 hours a day, 6 days a week. It's been actually the busiest 12 months in the last 48 years of business, which is phenomenal across all of our product range. In 1978, Stephen began making solid fuel back boilers. In the early 80s, then oil became cheap and he began making oil-fired boilers. I suppose there's been one of the things that Grant is very well known for is innovation and research and development, again driven by Stephen Grant, I suppose, and his team. But he then looked and made the world's one of the first condensing oil-fired boilers on the market, the Vortex boiler. At the moment, that particular boiler, as I said, we can't keep them made at the moment.
That's the one I have.
Yeah. To put a few figures on things, 70% of the boiler sold in Ireland, north and south, is a Grant boiler. And if you take GB, 60% of the GB market is Grant boilers. So there are many separate businesses, I suppose, running under the one roof, but oil-fired boilers are something that are still very, very, very busy.
Do you make all those boilers in Ireland then?
Yep.
They're all shipped to GB then?
Everything comes in as a sheet of steel or stainless steel, I suppose. One of the things, and where a lot of plumbers especially and merchants who sell all our products, it's the quality of what goes into them. So like we use 5mm steel, we use 316L stainless steel, we use Riello burners. And the model of that particular design of the boiler hasn't changed since 2002. There's a lot of very impressive statistics which we won't get into today, but just even on the boiler side of things, there's some of the first original condensing boilers that we've made. They're actually fitted quite locally to here, and they're still in and working away. Which
not still under warranty, of course.
Not under warranty, but like it's you do get what you pay for. As one plumber said to me recently, he said the one thing you need if you're going to go fit a Grant boiler is to check that you have two good tyres on his hand truck for moving it around, such as the weight of what's in them. But you do get what you pay for.
And do you see much of a shift from the oil boilers over to the other fuels these days?
I suppose there's two very distinct areas. If you're building a new build house, and we see this from a lot of the trade shows that we do, and in terms of even compliance with the building regulations, so you have Part F here for Northern Ireland, and you have similar as well in the Republic. Those regulations you have to show compliance, and the simplest method of getting compliance is with a heat pump. Grant have been doing heat pumps, I suppose, in GB since 2010. In 2015, we began selling heat pumps in Ireland, North and South. This was a product that we brought in from Japan. Very, very simple, very, very straightforward. Lots of installers liked it because, we put a lot of work into keeping it very simple for the installer. The main thing I do is I train the guys on how to be able to install them, but also how to service them afterwards. Included in the price, we'll commission them on site, which, as I mentioned earlier, it's not that we're checking up on the plumber, but we're just ensuring everything is correct. And when the homeowners there, will explain to the end user how to be able to operate this. And as part of the training, then the installer will be also able to do the servicing and the maintenance of it afterwards. So it ties everything nice and neatly back in together. The same as with the oil boilers. They can install the boilers and then they'll be also able to service and maintain them then afterwards. So it's the full circle, I suppose.
Okay.
Well, I know from my own experience, the heat pumps are technically more technically sort of challenging than the oil boilers, and I suppose the whole sort of design and installation of those is a much more complex thing. From my own sort of point of view and Passivhaus, we normally do underfloor. So they've got a package where you have underfloor, you've got your heat pump boiler, and you've got your cylinder and all of that together. Do you want to just talk about what Grant does in that space?
I suppose, we do something called a whole house package. So if it's, and there's two distinct areas here. So if you have a retrofit scenario or an extension to a house, that's kind of one aspect. The simplest is a new build project because the drawings will be emailed to us. We will do all the calculations and then we will size the heat pump. We will go with your radiators if that's your option, or steel radiators if you want steel radiators. You can have aluminium radiators if you want those, or if you want underfloor heating. There's a couple of principles, generic principles with heat pumps, and the first one being, the lower the flow temperature is, the more efficient the heat pump will be. Yeah. And underfloor heating runs at typically 35 degrees, so that is the best combination with a heat pump. Another little analogy, and I'm afraid I have many of them, a heat pump, what makes it efficient isn't necessarily down to the heat pump, it's down to the ability of the property to hold on to the heat. If you take a house from maybe 20 years ago, you could have had a heat loss of perhaps, at the high end of it, maybe 100 watts per square metre of a heat loss. Whereas if you build a new house today in Ireland, north or south, your heat loss is typically going to be about 35 watts per square metre. So that's a 65% increase in building efficiency in terms of retention of heat.
Retention of heat, but I would slightly disagree that it doesn't matter what, as long as the heat's going into it, the loss will be the same.
Technically, yes, heat loss is heat loss. But I suppose if you try to put a heat pump into an older house, it's like having
work.
It's like having the fridge and the door doesn't close properly. If the fridge door closes, your fridge won't be on very often. Whereas if you have a fridge and the door is slightly ajar,
it's a very good match for the highly efficient house.
Look, it's you can kind of make this as simple or as complicated as you want, but heat loss is heat moving to cold. Proper title is the second law of thermodynamics. But in simplicity, if you get a poker and you stick it into the fire, the top of the poker gets hot. That is heat moving to cold. So heat is like having a hole in a bucket. If you put water into the bucket, the water will find a hole. If you have a couple of gaps in your insulation, say for example where the insulation may come down towards the wall plate, the heat will go, oh, there's a gap out there. If the guy has pumped the wall and he's missed the spot, the heat will go out it goes. So I'm sure, look, you're more versed to this than I am, but like it's the whole envelope of the property. It's
the whole package,
so everything must tie together. The heat pump is the sizing of it is an awful lot more accurate. An oil boiler or a gas boiler is a rather blunt heat source, all right, in terms of it will keep sending heat
and more forgiving, I suppose, as well, because
it can overcome gaps in the insulation or the air tightness or the window doesn't close or the little bits that are missed. Whereas, and like one of the things that happens typically with a boiler is, on weather like this, you might have your thermostat set for your timer, shall I say, set for an hour in the morning and an hour in the evening, for an example. Whereas with your heat pump, you set the stat, and with all due respect, go away and leave it alone. Again, another silly analogy is you wouldn't, if your fridge at home isn't on a timer, you plug it into the wall, and when it gets to the desired temperature, it knocks off.
Yeah.
Your property, your new house, or your retrofit property, once it can hold the heat, it achieves the temperature of that, and then it knocks off. There are lots of other little things that's there, I suppose, and maybe some of the stories you hear with people out there is that about running costs. One of the big things is, unfortunately, some installers still think you use the same diameter pipe as what you use for a heat pump as what you do for an oil or gas boiler. Very short, simple explanation is if you take a standard 22mm copper pipe or a 3/4 inch copper pipe, you can get 23 kilowatts of heat through a pipe that's the size of my thumb. If I took away the boiler and I connected a heat pump onto that same pipe, you can only get 9.6 kilowatts of heat down through the same pipe.
Because it's run at a lower temperature.
So to overcome that, then you need to go up a size. Now, new build, that's fine because we put in accordingly. But if you go to a property down the way and they've had an old boiler, they take it out and try to connect onto the same pipework, the house has been insulated, maybe new radiators, new heat pump, but the pipework is under the ground is possibly undersized.
It's sized for the higher temperature oil boiler.
Cholesterol.
And people don't tell people that. Yeah, that's one of the issues.
This is one of the things there. I compare this to cholesterol. It's basically struggling to get the flow. It's a rubbish analogy, but you get the idea. There's lots of little aspects that's there that must be got right.
Is that for the likes of existing build? Is that something that you can then design around at your side if you have all the correct details from the start? Or is there an ideal new build side, existing type premises that people should be looking out for, that if they have these conditions met, they are ideal to install it, whether it's retrofit or new?
Yes, so this is something, and as I was mentioning beforehand, if you take for the Republic of Ireland, in order to get an SEAI grant, what would happen is the plans, a BER assessor will go out and they would have to achieve something called a HLI. I hear all these little acronyms. Heat loss indicator is what it means. And ultimately, initially, it meant that you had to be able to prove that your property was down to 48 watts per square metre of a heat loss. All right, and if you couldn't achieve that, you didn't get the incentive. That was it, and I agreed with that.
Correct,
it made perfect sense.
Absolutely,
because
that's your analogy earlier about keeping it hot and trying to.
Well, if you didn't, unfortunately, the warmest thing in the house is going to be your electricity meter spinning in circles. Because the heat pump is trying to put heat in there, and the house is just
it's just leaking it.
It's leaking out through.
Yeah.
So, that is your indicator. So what would happen is if someone's looking to retrofit a property, we would say, look, we need some sort of an investigation, and ideally with a set of plans. Now, if it's architectural plans, that's brilliant. I'm sure you can help with those. But even if it was just kind of a sketch on graph paper just for widths and the area of the room and what's involved with that. And from there then we can do, and it's what's called a room by room heat loss calculation. This is generic across the trade. So they work out how much heat each room needs, and then it's accumulated, and then you'll find out you need that size of a heat pump then. But that is the starting point. It's the same idea whether it's a new build or an existing property. The only difference being obviously if it's a new build property, it's 30-35 watts per square metre, and if it's a retrofit, you need to be able to get it ideally down around the 50 watts per square metre. Lower is better, but obviously there is the point of diminishing return where you have to throw a lot more at to get it.
Yeah. So Paul, if you were doing, say you had somebody come along, want to change my boiler and want to change it to a heat pump. If you take the oil boiler out and just put a heat pump in, it's not going to work because the radiators are sized.
And we get many people, I suppose, who would come to us because they see us as being unbiased. At this stage now, and I'll come to it later on in terms of the boiler side. The fuel that everybody is using is kerosene, but this year you're going to see the advent and the introduction of something called HVO, hydro-treated vegetable oil. It's a replacement for kerosene. Now, if you use
where does that come from? Is that like from crops or something?
It's actually predominantly made from used cooking oil. All right. Now there is a definite amount of it there.
Especially chip shops.
That's what it is, actually, yeah. So it's that type of oil. Okay, the small little bit that comes from your local chippers is going to be quite small in comparison, but it's generally large-scale food manufacturers, if you know what I mean.
Right.
So there's, I won't say like a huge volume of this. So, for example, there is one.
You're going to use a different word there, Keith. But
no, I'm very well behaved. I've had coffee. What happens, I suppose, is the treatment of how this is made. It's hydro treatment. So this vegetable oil is collected. There may be a small bit from, say, virgin rapeseed oil, but not a whole lot, and maybe a small drop from tallow from animal fats, but again, it's very, very small. It's predominantly used cooking oil. So it goes through 5 steps. So it's filtered, it's then it's strained again, and then it's soaked in hydrogen. And what that does is it causes the fuel to split. Top part is water, lower part then goes into a 4th stage, which is, for simplicity, it's like it's distilled. All right, and then the 5th stage is you could just take this and put it straight into a diesel engine. All right, the problem is there is a definite amount of it there. So if HVO, and there is HVO available in Ireland, north and south, but there are carbon taxes on it. Not one, but actually 2 carbon taxes. So HVO in Ireland, in Northern Ireland, it's about £2 a litre. All right, whereas down south, I think it's about about €1.60-ish. But so, and to be honest, there is a definite amount of it there, but you're never going to see it, in my opinion, across the whole country, because not only will heating come look for this, but so will transport, and so will agriculture, and so will fisheries. So one of the things, it's already began down south at the moment with one.
Is it any more efficient to use it by comparison to like oil or gas? Or
it's so small. If you use 1,000 litres of kerosene, the chances are you'll use the guts of 1,000 litres of HVO. But there's one supplier has begun, and there's a second one beginning this year to offer a blend on the market. So it's 20% HVO and 80% kerosene. All right, and one of the things, we had a meeting with a couple of governmental people in last year in 2025, and we were showing them the figures, and we're trying to explain that if every oil-fired boiler in Ireland, north and south, all right, that's 1.2 million oil-fired boilers, if they all went to using this blend, it would be the equivalent of retrofitting 160,000 homes with heat pumps in terms of carbon savings. And you make no adjustment to the boiler. Same boiler, same oil tank, same home, same radiators, same everything.
It's equivalent in terms of CO2 production.
Yes, it's probably the simplest gain that you can make in terms of climate action.
Does it have any downsides on the mechanical aspect? You know, the way they recently brought in the different fuels and petrol. Yeah. And if you let them sit, I'm a classic car fan, so if you let the car sit around for a while with the E10 in it, it will start to wreck the system, basically.
No, actually, it's a total opposite with HVO. HVO is typically used in an awful lot of cases for standby generators. Because if you put 1,000 litres, for example, or doesn't matter what the volume is, if you fill an oil tank with HVO, it's the same going in on day one as what it is in 10 years' time. No degradation of quality. As I mentioned, adds a slightly higher calorific value, but would you see it on average over 12 months? Not really. If you used 100% HVO, it's a 90% reduction in carbon. All right, so it's a massive reduction, but as I said, I personally don't believe there's going to be enough to go around. But
for those sorts of figures you're talking about.
Yeah, but the 20% blend, I think, is achievable. As you mentioned, it's if you stop at your diesel pump on the way home, or look at you'll see the amount of it's B9 or E9 or E10. Yeah. That's the amount of biofuel that is within this. Like, one of the things that will happen is, as this biofuel starts coming in, Grant, as an example, will have transitioned entirely to being 100% renewable energy company. Heat pumps, you know what I mean, oil-fired boilers running on biofuel, you know, it's an entire conversion over the years. But I suppose that's why Grant is still going as strong as it is after all these years, because we didn't just sit on our hands.
You adapt with the trends coming in.
Well, you have to keep moving along. So our R&D department are masters of coming up with new things that are needed for the industry, and then, you know, it's up to us just to get the installers up to speed. Then we've been able to install them and maintain them, and then that's how the industry moves forward.
In terms of heat pumps, the ROI building regulations brought in this regulation Part L or whatever it was, that you must have, I think it was originally 10% renewables. Yeah. And it used to be, people thought, oh, that was going to be solar panels or wind or something. But actually, a heat pump is considered a renewable.
Yes.
So that became the sort of default thing for developers, certainly.
Certainly, yeah.
Rather than having the cost of the heat pump, or sorry, the solar panels, just put in a heat pump instead. So that's created a large market, I would imagine.
There's a very, very large market there. So I would say the amount of new properties that are built, certainly down south, that don't have a heat pump, is a very small figure.
Any percentages?
I'm going to have a guess and say it's certainly below 10, and I wouldn't be surprised if it's below 5%. Yeah, you're probably looking at certainly over 90% of new build properties are heat pumps. So that's and one of the things, I suppose, it was the adaptation of this that was quite impressive, I have to say.
It was driven by the building regulations.
Oh, entirely so.
It was a financial driver as well, I think.
Well, as I say, if you built a new house in the morning and you wanted to have an oil or gas boiler there, you actually can, all right? But you must achieve your carbon savings. There's what's called an EPC and a CPC. Loads more of these little guys. But the main one there is the carbon side of it. You have to be able to prove you can offset that by typically using PV and a lot of PV, a higher grade of insulation, better glazing. In many cases, like mechanical ventilation, in many cases is pretty standard in a lot of new properties now down south. And I suppose those regulations came in the Republic of Ireland in 2017, and the regulations for Northern Ireland came along in 2022 or 2023.
But we don't have the same mandatory requirement for renewables.
No, but we're seeing a much greater interest in this.
Yes, we do some of the SAP assessments ourselves, and we find if you change in the Republic, be a deep assessment or a SAP assessment in the north, if you change the tab from oil-fired boiler to air source heat pump or whatever, ground source heat pump, immediately it becomes a heck of a lot easier to get a compliant building.
Yeah, one of the things we've seen with some of maybe the more savvy developers also is, in the old days they would do a show house, all right, and now a show house. Yeah, they'll have the show house there, and everything will be lovely and pretty, and there'll be a lovely bowl of oranges and apples there in the window, and all the usual stuff. And they will say, this house is being heated with a heat pump. Now, you could have this maybe with a standard gas boiler if you want. It's going to cost you a couple of quid extra. And one of the things a lot of developers have seen is homeowners will say, I'll have the heat pump, please. And it would go, oh. And it's been a little bit of a kind of an awakening moment that, someone's going to buy a property and potentially they're thinking, long term, we're going to be here for a good few years. And it's the buy-in, I suppose, that they see there. And people aren't just taking a chance on this. Years ago, people would go to trade shows and they'd stand in front of a heat pump and say, what's that thing? How does it work? Whereas now what happens is you'll see people coming to trade shows and they'll come up there and they'll have it marked and go, yes, so my plumber was recommending this is the heat pump here he wants to fit. And he said, I'm getting a 4 kilowatt or a 16 kilowatt or whatever it is in between. And in some cases, it's just to see what we're getting before the house goes in. So it is gaining traction.
Yeah, I think when you're saying that, I think in the last number of years, people associate heat pumps with, energy efficiency, which is one thing. They also associate it with being environmentally friendly and more environmentally friendly than using gas, even though, it is more environmentally friendly.
Yeah.
Particularly where the electric comes from is another story. But
actually, there's a very interesting thing that I do when we do training courses. We have a look at AirGrid dashboard. All right, so anybody who's listening to this can throw that into the search engine. And what that will do is it will take you to, basically it'll show you where your electricity is coming from at this very moment in time. And the electricity grid in Ireland, north and south, is pretty much all the same, so you're not going to see any real difference there. And what it has shown is, on average, every year for the last couple of years, the greener energies, now predominantly wind turbines, it is more and more of our electricity is greener. All right. Now, when you have, like we've had in the last couple of days, very windy conditions, you could be seeing conditions, or you could be seeing readings of maybe 60-70% of our electricity today has been generated from green sources. All right. Yeah, now, if you look, but if you come back, for example, and have a look at this, all right, so you'll have the fors and the against. The against will say, yeah, but if you look at it in the middle of the summertime, it's very, very little. And that's because it's typically calmer. Yeah. So, but look,
your PV kicks in then. If your
PV, we find, in my opinion, is brilliant for your property, but as a net contributor to the grid, it doesn't typically show, because I've seen, for example, in the summertime, all right, June, July, and August, renewables, I've seen it down as low as 10%, and in some cases below 5%. So that is when it's really calm, there is no wind, the turbines aren't spinning. So that's a little bit from PV, and people are selling it back onto the grid and stuff like that. But PV is brilliant in your home, and for offsetting your electrical costs. And if you have a heat pump, it's a bit of a no-brainer, because it's going to offset some of the running costs of your heat pump. You can use a thing called an eddy, which means it'll heat your hot water cylinder for you, which means your heat pump may not even have to turn on during the summertime in that scenario. So that's everything ties back in together.
I think just getting back to the amount of the energy that's now coming, the electric that's now coming from renewables, I think that also helps whenever you swap to a heat pump on the calculations, because it now knows that is not coming predominantly from fossil fuels.
Yes.
A good percentage of that is coming from renewable, and therefore it's more kind to the calculation for the heat pump. I think that's part of it as well.
Certainly it is. I suppose from our point of view, we're kind of pretty much unbiased in that it's an all controllable as far as me or you or really any of us. Right. What's driving our lights here today, what's driving the screens here today, it's pretty much, whatever comes through, it is what it is. But it is getting greener. Will it ever do everything? We're a little rock on the edge of Europe with something called the Atlantic to the left-hand side. Will we end up with the whole place covered in wind turbines 3 years to come? We don't know. There's no magic. There is no magic solution.
I think that's the perception behind the adoption of heat pumps, that they're thinking that if you do use it, it eventually will be a green grid, and therefore it'll be carbon neutral. That's my perception anyway.
Yeah. Look, it's the way it's going. So, another aspect of that, I suppose, to kind of have a flick the other side of the coin, is we get, I won't put a figure, but a huge amount of people every year who have an existing property. And
old leaky properties,
or even maybe a property built in the last 10, 15 years. All right, 20-year-old property, all right, with radiators and underfloor heating or something like that. And maybe they don't want to put in a heat pump for whatever reason. Maybe they don't want the disruption of having to upgrade their pipework sizes and all that sort of stuff. And, our advice to them would be, get someone in to have a look at your insulation and air tightness. You're no better than I, but in terms of products on the market there to, again, improve your ability to hold the heat. And there are a huge amount of people out there still, because we meet them at trade shows and they ring us in, they would say, I have an old standard efficiency boiler. And there's a very simple number there. If you were to go from a standard efficiency oil-fired boiler to
85% or so, if you're lucky, 80% or something like that.
And there's a little bit of a twist on that, because you have gross efficiency and net efficiency. Yeah. There's a very simple number to go. If you had an old standard efficiency boiler and if you went to a Vortex boiler, you're looking at a third less fuel.
A third.
Right.
And that's not
terms. Yeah, that's not me sticking my head on a block or anything. And there's some old cast iron boilers that went in the 70s.
The really old ones.
Yeah, probably at this stage more fire spent than there is cast iron in them. The major difference is the temperature going up the chimney in those could be 300, 400 degrees, whereas on a condensing boiler it's 65 or 70 degrees.
You can put your hand over the flue and it doesn't.
It's the same temperature typically as what you have coming off a radiator. So look, it's just there's it's a very wide demographic of people that we get in contact with us. If it's a new property, no problem at all. You can have pretty much whatever you want. You have an existing property, you are more than likely, if you have an oil-fired boiler, going to end up going to a condensing boiler. The services, like people say there's a massive difference between them. There isn't a risk. The sizing of a heat pump, I suppose, is done by the likes of us. So we'll size the heat pump, we'll size the radiators and the underfloor heating and the cylinder and all that sort of stuff, and that's fine. If you get an oil-fired boiler, your installer can size the boiler for you. They will size the radiators as they have traditionally for many years.
Yeah, it's more straightforward in that sense.
And off you go. But I suppose one of the big things that's there again, which it's 2002 since we started doing the Vortex oil boilers, but it's sizing is still very important. Someone goes to a property and say there's an old 9120, which is a 26 to 36 kilowatt boiler, and they'd say, I'd like to put, I want to put a new condensing boiler back in, and their installer hopefully will kind of say, I don't size the boiler off of what was there previously. I'm going to do a heat loss calculation on the property, because the first basic rule with a condensing boiler is that you don't want to oversize it. The harder you work it, the more efficient it is. So as a very quick rule of thumb, and it's only an indication, anything up to about 250 square meters of a property of average insulation, average doors, average windows, average everything, that would probably be a 26 kilowatt boiler. All right.
Yeah.
Whereas if you kind of go to maybe 350 square meters, that's probably a 36 kilowatt.
And I know money was that, like they talk about 70, 90 and all that sort of
At
stuff.
90, yeah, a 50 to 90 would be 50,000 BTUs to 90,000 BTUs. That would be about 2,500 square feet roughly, and a 90 to 120,000 BTUs would be up to about 3,500 square feet. Very, very roughly, as an indication more so than anything else. But again, the heating and plumbing contractor will do heat loss calculation and go from there.
So for existing build, is there any sort of scenario where you're sort of thinking you're probably better just to stay away from the likes of heat source, or if a client was adamant they want it, are there any sites that are more sort of set up for it?
Something that we were speaking about previously was if you build an extension to the back of your house, your new part built to current standards is going to need very, very little heat. But if you wanted to put a heat pump in there, the rest of your property needs to be taken to, dare I say, fairly close to the same standard as what you've just built.
So in an ideal world, you'd want the type of client who's gotten the whole house whilst putting an extension. Yeah. It's not really as feasible to.
And to be really honest with you, if you can't do that, well then, dare I say, don't fit a heat pump. All right, it's in my opinion, it's that
you're not
kind
going
of
to
a
get the full value out of it.
You're going to have high run costs and you're going to have poor performance because the heat pump is going to be constantly on. Something as silly as, we have lovely old open fireplaces. Well, you won't have a heat pump then. Why? Well, you can open the top sash of the window wider if you want to let all the heat out through there. We get lots of people building properties nowadays and they like to have a stove in their house, just a room heater stove. That's actually fine. Get a room seal stove, which means the air supply is ducted to outside. Because other than that, you're going to have a 100 or 150 mil or a 6-inch hole in the wall for air supply in. And if air can come in, heat can go out. So look, it isn't one major thing. There's lots of certain little things that everything must be lined up with, and it's from the very, very beginning, from the stage where you guys get involved right through to the end of when it's been commissioned and the handover is being done. All the stages need to be correct for a new build property. If you have an existing property, I said a boiler is a blunter heat source. It's in many regards, your controls, you can have whatever controls you want, but a boiler is kind of like a light bulb. It comes on when it's told to come on and it turns off when it's told to turn off.
If you have an old leaky property, and this is the one I actually live in, I live in an old 1970s bungalow currently. In the morning we turn the heat on, oil burner comes on, blasts the heat out, it's warm for a couple of hours, goes cold, in the evening time it comes on again, blasts the heat out again for 2 or 3 hours, whatever, and then it goes cold during the night. And that kind of works on those short terms.
Yes.
But that's because it's the only way we can really do it efficiently.
Correct, yeah. And your heating curve is
like
this. Whereas if you had a heat pump in a property, your heating curve is a little bit like this. And again, there's a little silly thing like that. If you had an oil boiler or a gas boiler, the more thermostats you put in the house, the better.
Yeah.
That's what people perceive. If you have a heat pump, that's the worst thing you can do. All right. We'll keep it simple. Say if you have a 2-story house, standard 3 or 4 bedroom semi-D. Well, no rocket science here. The best and most efficient way to control anyone's heat pump is one thermostat upstairs and one thermostat downstairs. Because if you have, for example, someone says, well, I'd like to kind of keep the master bedroom upstairs at 18 degrees, but we have the baby's room next door and we'd like to keep that at 20. There's a little thing called physics that says, no, heat moves the cold. All right. And it will go through the wall because there's U values and stuff, but heat, like water, takes the path of least resistance. It'll go, that door is open, we'll go out there, and then we'll come back in here. And after a while what happens is the whole house ends up being at one level. But all that happens is if you have lots of different thermostats on, or the classic example of the spare room, all right, so there's the ladder, there's the buckets of paint, and there's the boxes of stuff that you should have left in the old house or in the bin. They're all stacked in there, and somebody sets the thermostat at 16 degrees. The room beside them is at 20. So that room won't stay at 16. The only difference is now, say if you had a radiator in the room at 20, that radiator is constantly on because it's trying to get this thermostat up to 20 degrees and it's losing heat out into the room that's at 16. So one thermostat upstairs, one thermostat downstairs. It sounds contradictory, but the lesser amount of control you have with a heat pump, the more efficient the heat pump system will be.
That's because it's not switching on and off all the time.
Exactly. And all that does happen is little bit of heat in there to that circuit, that knocks off. Downstairs up the temperature, that knocks off. Another little thing that we hear people saying is it true that now that I have a heat pump that I can't open my windows?
They say that about passive houses as well,
yes.
Which of course isn't true.
My answer to that would be, if you're driving along the road, if you have air conditioning in your car and you want to open the window, what do? You turn off your air conditioning and you open the window.
Yeah.
And then if you want to put it back on again, I'm full of analogies, you let the window back up and you turn your aircon back on. If you have a home and you have a heat pump and you want to open your window, turn your stat down and open your window. Just remember this evening before it gets cold to close the windows and turn your thermostat back up again. So it's
common sense.
It is, but sometimes you have to say it out loud to go, oh God, yeah, I never thought of that. So
the old saying, common sense isn't that common now.
There's lots of sayings about that, but maybe not fit for recording.
So on that point, what way do heat pumps work, just for anyone who is completely new to it?
Everybody's heard the expression that a heat pump works like a fridge in reverse. You heard that before?
I heard that one,
well, that's wrong. All right. A heat pump works the very same as a fridge. What does a fridge do? A fridge takes the heat that's within the fridge and it dumps it out through a grill at the back.
That's right.
All right. A heat pump, what it will do is it'll take the heat that's outside and it transfers it into something called a heat exchanger inside. So, and there are different types of heat pump actually, now that we mentioned it. So the one that Grant supplied, the Arona R290, that's our current heat pump. The R290 heat pump, it's an air source heat pump, an air source monoblock. So simply what that means is the heat pump is situated outside, ideally south facing actually if you can. All right. All these little things add up. Where does the dog lie? He lies in the sun. Why? Because he's not silly. Heat pumps like warm air. So if you can get a heat pump in a south facing aspect, please do. East or west, grand. If it has to go on the north facing side, the heat pump will work. But you could be in the shade, which means the air is a little bit cooler. It will work, but again, all these little things help.
Not as efficiently, just.
Yeah, it's
because the air's a little bit cooler.
You bearing in mind, and actually, and I'll come back to our question in a second, even where you site your hot water cylinder, try have it centralised as close to where your hot water outlets are, so that you're not having what we call dead legs. All right. To go back to your heat pump, an air source heat pump, what it does is it typically sits outside your property, 300 mil away from the wall, and when the heat pump starts, the fan, you'll see the fan turning inside, and it draws the outdoor ambient air out through a grill at the back of the heat pump. That's not looking too dissimilar to the radiator that's in a car. And within that grill is a series of tubes which is filled with a liquid refrigerant. This is where it gets a little bit nutty. There's enough heat in the air, even if it's minus 40 degrees outside, to cause that refrigerant to boil and turn into a vapour. Now, if that doesn't make sense, don't worry about it. This is how your fridge has worked for years.
What temperature refrigerant? It must be colder than 40 then.
The refrigerant R290 is simply propane. Propane is a brilliant refrigerant. All right. Previously to this, we used stuff called R32, but we won't get into that today. But even down as low as its thermodynamics, even down to minus 40, minus 44 degrees, there's enough heat in the air to cause that refrigerant to boil. All right. So for simplicity, you'll start over here at your fan unit, and you have a warm vapour coming up from that at about, say, 15 degrees to pick a handy number. And then it goes into the next unit. There's 4 main units. The second unit is something called a compressor, and this is the main working part of any heat pump, any aircon unit, any fridge. And as the name suggests, it takes that 15 degrees of a vapour and it compresses it. Now, every kid at some stage would have got a bicycle pump and put their finger on top of it and pumped up the bicycle pump. What happens to your finger at the top of the bicycle pump?
And it's hot.
Yes. Where does the heat come from? If you compress a gas, you raise its temperature. It's called a pressure law in physics. I wasn't listening that day either, but that's what happens. It'll come in at 15 degrees and you compress it, and it'll leave, say, at 45. If you wanted it warmer, you'll compress it some more. Now it's up to 50. You want higher? No problem. But the more you compress it, the more electricity you use, which leads back to one of my earlier principles. The lower the flow temperature, the more efficient the heat pump will be. For simplicity, for the explanation, 50 degrees will leave as a high temperature vapour and next go into what we call a heat exchanger. Now, a heat exchanger is very simply is 4 connections. You have your hot refrigerant gas coming in at the top, and from the side of it you have your flow and return, the same as you had from your oil boiler or your gas boiler. So the cold return will come back from your underfloor heating and from your radiators or wherever. It goes in through your heat exchanger, it takes the heat from the hot gas and heads back out and into your house as the flow. To heat your radiators, to heat your underfloor heating, to heat the coil inside in your hot water cylinder. And it'll keep taking the energy from that hot refrigerant until it's changed, it's lost all its energy. what happens to the steam when it comes out of the kettle, when it hits the tiles? It changes state from a vapour back into a liquid. So once it loses all its energy, the refrigerant within the heat exchanger changes back into a liquid refrigerant. It trundles back along the bottom to go back into the fan unit to start it all over again. It's called a vapour compression cycle. There's nothing really new about this. Lord Kelvin was playing with this in the 1850s. The cycle itself hasn't actually evolved. There's been minuscule changes between little bits of efficiencies here and there, but that is in essence how a heat pump works.
Okay. So what heat pumps do Grant actually do then?
So we do a range in terms of sizes, I suppose. So the size of the heat pump would depend on the property. So we do a 4 kilowatt, 4, 6.5, a 9, 12 and a 16. But one of the things that a heat pump does is, and this is generic with lots of different heat pumps, it has what's called an inverter within the unit. And very simply, what you can equate it to how a gas boiler modulates. If you had a 2-story house and the upstairs circuit shuts off, your 4 kilowatt heat pump will then start slowing back down to 3, down to 2, down to probably 1.5 kilowatts. So it only generates the amount of energy that it needs. All right. There's lots of other little things different, I suppose, that we've done with this. The particular heat pump we do is, we can very confidently say, it's the only heat pump that has been designed especially for the Irish and UK market. All right, there's, in terms of the humidity, all right, we spent over €1 million on a climate chamber. It's the only one of its type in Ireland and the UK that allowed us to be able to test these heat pumps even down to -20 with a humidity of 85 or 90% humidity in these sort of conditions. So we've put these things through its paces.
You're able to create the real world conditions, really.
We were able to create what happens out there in the real world, and there's lots of different things. The casings, they're galvanized and they're powder coated, so if they're in a coastal area, it's fine. All right. Like typically what you used to see in some cases is lots of people used to fit what they call a ground source heat pump or geothermal. All right, brilliant units, very efficient and the whole lot, but one of the problems is you have to test the soil. You need what's called a damp cohesive soil. If you have a sandy soil, for example, there's no heat in sand, so that's not very good. Or else you may have to drill a well or maybe 2 wells. So geothermal actually might be slightly more efficient, but your initial outlay could be 2 or 3 times the price, and you'll probably never see it back.
Certain sites it won't work on.
Exactly. How you compare apples with apples is somebody will say to you, well, what's the most efficient heat pump? You will get your brochure and you will look up the SCOP of the unit, and that stands for seasonal coefficient of performance. In essence, this is the miles per gallon equivalent of a heat pump, and it's always expressed as a ratio. So if you wanted to say, what's the efficiency of that 9120 Vortex boiler, that's 97% efficient. Heat pumps efficiencies are expressed as a ratio. So for example, we have a heat pump there and it's 4.88 to 1. What that means is if you put in 1 kilowatt of electricity, you will get 4.88 kilowatts of heat energy from it.
Oh, there's a caveat to that, isn't there?
No.
Not when it's -20 outside.
Typically, yes. What they used to have was, you're typically measuring down at, the heat pump is rated at -3. All right.
Right.
But one of the things that we've done with this is, if you take our 4 kilowatt or any of our heat pumps, that would give you 4 kilowatts of heat at -3.
At -3.
Yeah. Typically, the old standard was at a 35-degree floor temperature, which would be typical for underfloor heating. Yeah. But what we can do now is we can say that 4 kilowatt heat pump will give you 4 kilowatts of heat at -3 at a 55-degree floor temperature, which is heating the coil of your cylinder, and even down as far as -5. So we've kind of gone beyond the power and capability of what's in these R290 heat pumps of ours is outstanding. Because typically what used to happen is once you got below, the original standard was 7 degrees. Heat pumps were typically rated, and our previous R32 version was the same. It would give you the amount of heat at 7 degrees outside, and as the temperature outside cooled, the output and the efficiency dropped off. Now that's not the case.
Yeah, you're saying Grant boilers don't do that?
Your own heat pumps. If you take boilers, heat pumps. It will deliver what it says. It does what it says on the tin. We've done this through very clever design. All right, the speed of the compressor, the speed of the fan, and all this sort of stuff. But it now does what it says on the tin. And I suppose when the drawings come to us and we do the calculation, we're declaring that heat pump will heat your property. So it's not a you have a company like Grant saying that will heat your property that will heat your property. So the amount of capability that is within this unit is phenomenal. Like there's nobody, and I'm pretty safe in saying this, has ever done the amount of testing on heat pumps for the Irish and UK market, especially for that. So it's a huge plus. We sailed through the last winter, thankfully, and not one phone call.
One of the things when you talk about humidity in Ireland, one of the anecdotal complaints I heard about heat pumps was that they freeze up in the winter time. Do you want to speak about that?
Yeah, this happens for a couple of reasons. Number one is if the unit isn't sized correctly. All right, but Grant are kind of widely recognised within the industry for having the most accurate heat class calculations out there. The second thing can happen is if the property is not doing its job in terms of holding on to energy.
Right.
So the heat pump is working so hard trying to get the property up to temperature that it's working so hard in cold weather that it freezes up. Now, most heat pumps can just start up and do a defrost and off they go. Again, one of the other things we do with this is we've done something very clever. What happens in a defrost is that cycle I mentioned earlier on of where it goes from the fan unit into the compressor into the heat exchanger. How a heat pump does a defrost is it changes direction. So it takes a little bit of heat from the heat exchanger and the compressor pumps back heat into the fan unit and it melts the ice off the unit. We have developed something called a mini defrost where we're able to balance this out in such a way as that the ice doesn't build up, and if it does have to, it's a very short cycle to be able to do it.
Yeah.
Because the problem with defrost is there's no heat going in, and it can be hard enough on electricity when it's doing this. So again, the defrost cycle on this is very, very clever again in how it operates.
Okay.
And it's something that is between +3 and -3 with high humidity, foggy mornings, muggy mornings like that. They can be a killer on heat pump, and exactly what you mentioned then, Paul, is what will happen. So with these, because of the sizing of them, and there is one other that ties back down to what I said earlier on about the thermostats. We try to, encourage the end user to listen to what we say. Minimise your controls. Thermostatic radiator valves with heat pumps shouldn't have any.
Yeah, because they're working against it, aren't they? Really?
Exactly. Heat pumps need volume and heat pumps need flow.
Yeah.
So if you just have your thermostat in there, it has all its volume. Your heating curve is nice and flat like this, and that's what you're looking to achieve, and that's how you have an efficient system. And when you do that sort of stuff, you have an efficient system that's easy to run, and simply no phone call back for Grant or for the end user or anybody like that.
Some ways less is more.
Less is more. Less is more.
I heard that about the two thermostats, and I was kind of skeptical about why you couldn't have different temperatures in each room. But what you're saying is the heat just moves through the wall.
Yeah. Now, you can zone where you need to. So a prime example would be, say if you were after designing a lovely property and it's looking out at the bay or at wherever, and you have a lot of glass south facing. Yeah. All right. In that area there, you probably would put a thermostat there
because of bigger swings. Yeah.
Because of solar gain. So the sun is shining in through your large glazed area, and if your thermostat here set at 18 degrees, and it's up to 18 degrees, so it wouldn't heat that side. But the north-facing side, for example, may need a little bit. So put thermostats where you need them, but don't just start putting them in just for the sake of them. This is kind of the strategy that you want to be employing that's there. And like one of the things we do when we do the training courses, and as you mentioned, your points there are some points that I hear every day from, whether it's the plumber, whether it's the electrician, whether it's the designer, whether it's they come in with the questions and ask your questions. That if not, look, we'll come to that in 2 minutes and we'll explain why you minimise that, why you want to have what's called an open loop heating system, which is minimising your controls and guaranteeing volume to your heat pump and stuff like this. There's lots and lots of different things, and every house is different. So even in terms of something as silly as your hot water cylinder, like Grant now make their own hot water cylinders as well down in Birr and Offaly.
And that works with a heat pump, does it?
Yeah, exactly. Like we've developed this in terms of even the surface area of the coil is massive. The insulation that we use, there is one step up from everything else that's there as well. Our testing procedures, as Stephen Grant dictates, is extensive. It's funny you say that, Keith, because we had one house and one of the issues was it was a heat pump. One of the issues was a lack of hot water, but I think it's because of the lower temperature. And we actually think that the plumber put the wrong cylinder in. The cylinder was changed now, and we don't know what happened. But the coil that you have, say for example, off of an oil or gas boiler, just for simplicity, maybe 3 meters long of a coil. Whereas if you had a coil for a heat pump, it's typically about 8 meters long of a coil.
Yeah.
So the surface area of the coil is an awful lot larger. Now, one of the other things that happens as well with a heat pump is it will run away and it gives you either what we call hot water priority. So it's either A or B. Like a combi boiler, I suppose, in many regards. So if it's on central heating mode, there's no heat going to the cylinder, and you have 2 different temperatures. So ideally, if you had underfloor heating, there's 35 degrees, and that'll do a lovely job on your underfloor heating. And somebody jumps in and they have a shower, all right. And there's a temperature sensor in the cylinder. It detects that the water is after getting a little bit cooler, so it'll stop putting any energy into the underfloor heating, and the valve will open and now it'll start heating the cylinder. But the heat pump will change from, say, a 35 degree flow up to a 55 degree flow. Heat the cylinder up to temperature, cylinder is satisfied, that valve shuts off, and if there's a heating demand, it goes back to the heating.
It knows to change the temperature when it's heating the cylinder?
Yeah.
Didn't know that.
Yeah, all that does a Legionella cycle, another box.
Yes,
that's
right.
tick, that'll do that.
Yeah.
Again, our guys, when we go out to commission the heat pump, all right, so we have guys north and south, and that's pretty much all they do, is they go out full-time commissioning heat pumps then for installers. You know, it's going out there, and every property is different. You could have a brand new property, underfloor heating, upstairs and downstairs, that's fine. You could have a property where it's have to be a retrofit, and they're going to go with radiators or something like that. Every property is different, so we would have done the design calculations, and the guys would go out to commission them, then would set that up to match those design specifications.
Just when you're talking about design, one of the kind of, I see it as an open market here. There's a lot of architects who design houses. They're highly efficient, the fabric's very efficient, but when they go to get their heat pump, their underfloor designed, all of that, there doesn't seem to be a one-stop shop for that sort of solution where because it does all have to work together. Do you want to comment on that?
Yeah, so when we get the plans, I suppose we will design the whole lot. So we will say, there's the size of the heat pump you need. There is your underfloor heating or your radiators. There's your controls. And I briefly mentioned earlier on about the hot water cylinders. We do different types of hot water cylinders. So you can get your standard stainless steel cylinder, and your plumber connects it up as you would have done previously. But one of the most expensive things on a project is labour. All right, so we have developed something called a pre-plumb cylinder, and simply all that happens is the plumber will take this out of the box, slide it into the corner, and it's pretty much flowing in front from the heat pump goes in there and there. The upstairs 2 circuits goes in there, the ground floor circuit goes in there, cold supply in, hot water out to the bathrooms, the cold to the bathrooms, and then for the sparks, for the electricians, it's all free. It's probably the simplest heat pump to wire up in the industry. So 2 cables out to the heat pump, a 3-core supply and a 2-core 0.5, that's your heat pump wired. All right. We do another option then called an A-wave cylinder, which is like a large white cabinet. It looks like a really big fridge. So for example, a lot of developers love this because in essence it's a plant room or a hot press in the box. Yeah. So this will sit in the utility room. It's a really pretty looking big white box, but I think it's pretty. Your little display pad is there. The controls that we have nowadays, you can have them on your phone. You can see them as there. They're very intuitive. The thermostats that we use also, in conjunction with our heat pump, is very smart in that, you know, there's lots of thermostats out there. Once they get to 20 degrees, they turn off the heat pump or turn off the boiler or whatever it is. The thermostats we've developed will tell the heat pump, say for example, if you had underfloor heating at, that's just to pick a number, at 0.6 degrees below the set point, it will tell the heat pump, you can start slowing down here now. I'm nearly here to temperature. What happens is otherwise, if you just had a regular thermostat.
Modulating, you call that, or what's the fancy
well,
that's a different thing, is it?
It is actually, it tells the heat pump it can start using the inverter and modulating back down, because otherwise what happens, if you have underfloor heating, you keep charging energy into the floor, the thermal mass, and at 20 degrees it goes, stop.
Oh, it's too late.
But you have a 20 degrees, so the thermal mass then will give off its, and you have the heat soaking up. With this, it's very, very, very accurate.
But predictive.
Exactly. So it ties all this sort of stuff. Like, it's not just we've made a heat pump. All right, we've done pretty much the whole system. Like that particular unit I was mentioning earlier on, we call it an A-wave cylinder. Lots of developers love that because you can literally place it in your utility room. It's the same size in terms of footprint as a fridge or a dishwasher or a tumble dryer. The heat pump will typically go outside that, and everything is just plumbed to it and plumbed away from it and wired to it and wired away from it. And it's a very compact source, and it speeds up. Like I've spoken with contractors who can connect up to 7 cylinders in a day. because say a timber frame house as an example, the pipework was just sticking out from it. Now you can also run the pipework up behind it or either side of it. There's kind of two little side plinths that we have to hide the pipework. But in many cases, the plumber comes back the second fix and there's 7 pipes, and he can just cut them off and elbows and tees and onto the next one, and Sparks comes in and he's a few cables into it and off he goes.
Plumbers are going to love that.
Plumbers love it, electricians love it,
developers love it.
Everyone loves it, and the end user, I suppose, from our point of view, all the parts that you need are fitted. So the filling loop is there and everything is there. Like I was mentioning earlier on about the controls and the smart controls that we have, and a brilliant example was I was in our technical department one day and a customer rang in and they were saying that the water coming from their taps for the last couple of months is perfect, but in the last 10 days it's not quite hot enough. So we got the details from his controller, and with their permission we can log on remotely.
Oh, so is there like sort of Wi-Fi thing?
Yeah. So it links to so like we supply the little Wi-Fi router there as such. So literally the homeowner goes in, puts in their details, and obviously for GDPR they have to give us their permission. Yeah. And we could go in and the guys had a look at this for this particular customer, and they could say, last Saturday at 3:15, somebody went in and changed the temperature in the hot water cylinder down to 32 degrees, and they went, oh. And our guy said, well, you know, I could turn it up for you if you want. And he said, oh yes, please. So remotely, all right, probably 2 hours away, we were able to put the temperature of the cylinder back up to where it was. And we said, now, you know, see if you can find out who was playing with the settings and say, look, it's well enough. Yeah. But previously, you know, we're going to have to try to talk someone over the phone, or the installer would have to go back out, or one of our technicians would have to go back out, you know, in terms of running costs, in terms of everything.
Well, that brings me on. Is there a way then you can do that? And everyone's using their phones, their iPhones, whatever. And is it controllable from your phone then?
Yeah, you can see everything there on your phone. You can go in there, you can see it. Now, you know, it's not like you're going to be coming home from work or coming home from school or coming home from wherever and you want to turn your heating on. But if you want to check anything or something like this, I suppose, even if you want to, you know, adjust the temperature, you know, you can walk over there and turn up the temperature, but if you're a little bit lazy, you could pick up your phone and just kind of go. Good. But it's the way a lot of this stuff is going now. The controller itself, I suppose, we put a huge amount of work into this, and we launched it at the installer show in Birmingham in May from 2 years ago, and back then it was widely regarded as the best and simplest, a very intuitive controller. And last year, after 12 months, it was still considered the same, and lots of people love it for that point of view. It's simplicity, really. It's like when you get a new TV. You know, you can just go through the settings there if you're looking for your hot water, or if you want to time it. If you have night ray electricity, you can use that there to do your timings inside and that as well. Yeah. So, you know, it's not just a heat pump as it was now. It's a myriad of different things, but we designed the whole lot. We'll show your plumber how to plumb it up, your electrician how to wire it up. We'll commission it when it's finished. There's a whole load of YouTube videos as well. So how typically in the old days somebody would say, Keith, how do I know how to operate this thing? You'd say, there's the book, go away now and have a look at that. Where nowadays it's, if you go onto our YouTube channel, Grant Engineering, there's a little 1.5 minute video there of
all the various parts,
how to pair a wireless thermostat or something like that. And you know, that's how consumers nowadays they go in there, they can watch a little 1.5 minute video on YouTube, they can see how to set it up, see how to operate it, and it's there then as an asset for down the line if it's ever needed afterwards. So it just ties everything very neatly back in together. So
yeah, I just want to say, Keith, I really appreciate you coming along today. I certainly, from my point of view, I've learned quite a bit about heat pumps and about controls and all the rest. I don't know about yourself, Paul.
Very much so. Yeah, thank you very much for coming along. It's been very informative.
Do you want to give us your sort of contact details for going forward? Yeah,
certainly. If any questions or queries on any Grant products, I suppose the starting point would be our website. So www.grant.ie, or if you're in Northern Ireland, it's www.grantni.com. And across all the social media channels, if you have a look there, whether it's, you know, there's a lot of them out there now, we're across the whole lot of them. So
or just pick up the phone.
Or pick up the phone. This is something that we emphasise.
Yeah, exactly.
It is, but it's funny because there's people that we speak to who have been in the trade for 30 and 40 years, and it's the same people that they've been ringing and asking questions, and all of our questions, not all of them, but a lot of the questions we get are only short questions, 30 seconds, 1 minute, thanks very much, bye-bye, and off we go. And they can get the project finished, whether they're the plumber, the electrician, the architect, the engineer, the energy assessor, or whatever you're looking for.
Brilliant.
Thank you. Thank you very much.
Thank you very
much, guys.
Excellent.